Hi, people. I'm just doing a little bit of pre-stuff that doesn't matter right now while we wait for people to show up. I almost want to make a function that just parses comma modifiers and returns identifiers. Because I just have a bunch of loops for this, and it's more code than we need. But it's not quite enough yet to justify doing that. But we'll get there eventually. Okay. So you could say logical Okay. None of this stuff really matters yet. Um, okay. Why does everyone raid me? I don't know. Hello, people. What have you been doing? What's been happening? Yeah, it's not like Devin's a random person. I mean, maybe. Maybe he's a random person. I don't know. Okay. So, I've got a little bit of a headache all of a sudden. Whoa, that was a trip. I need to do a little bit of a neck stretch. Wow. Yeah, ugh. You're too old to drive. From your understanding, the no check cast flag will make any cast errors silently fail. No, that's not what that means. It doesn't mean silently fail. It means that it will do whatever the cast does by default. It's still well defined. Like you'll just so if you don't put a no check on there, then for example, if you cast down to U8, you're kind of implicitly saying this number is going to be between 0 and 255. All right? If it's not between 0 and 255, it's well defined what the result is. It's just that might not be what you expected from the program, right? So that's why those checks are on there. I need one of those electronic standing desks. I have one of those electronic standing desks. I just never adjust it. It's not even plugged in right now. But that is what I'm using. Okay. So I'm just going to add some flags while people are showing up, and then we'll do the interesting work. I don't think we're actually going to use these flags yet. These are just some things we might want to use later. And the reason I'm saying marked as is that these are like user flags that are actually syntactical, right? But you might decide, so one reason you wouldn't want to check the shift is because the user said not to, right? But another reason might just be that at type inference time, you know that it's a shift by a constant that's less than the word size, right? Or maybe the optimizer later does data flow analysis and sees bounds on the number that could be passed and that it's always smaller than the word size. In those cases, you might flag it, but you want to have a clear difference of whether it happened because the user did it or not. Okay. So now, where do we stick this? We have if it's a binary operator, so if it's this, whoops. Or this, then parse, what was it called? Parse, comma, modifiers for shifts with that. It's called operator, not operation. Jeez. Jeez Louise. Operator. Okay, let's see if this compiles. Did I even check in earlier today? I don't even know. I guess so, I did, yeah. Okay. C++ sucks. All right, we're not gonna. Is there like a good way now to do? If I want to have strongly typed flags, can I do that without doing a giant template mess? Or am I just going to do this? Oh, maybe it'll work if it's U16. No. This is such a garbage programming language, man. It just gets worse and worse. Like, once you've been using a language that just doesn't have these problems, and they're such simple problems, and then those committee people have been working on crazy things for years. All right, we're not going to have strongly typed flags because C++ is a jerk. Okay. Involved writing operator overloads? Yeah, that's out of the question. It's a bummer. It's so ridiculous. Like, flag mistakes are very common. I know they're among, the more common of the kinds of mistakes that I make, for sure. And it's so easy to prevent that. Like, do that instead of like adding monads to C++22. Like, what is your problem? Enum class, maybe. Yeah, what does that do? Let me read. Enum class on cppreference.com. Class. What the hell? Enum struct. Scoped enumeration, whose underlying type is int, or I guess this type. Oh my god, dude. This is the worst documentation. Okay. Each enumerator becomes a named constant. It's contained in the scope of the enumeration. Oh, that's just not putting it in global scope. That doesn't help. That doesn't solve anything. All right, whatever. The whole point of all of this is that we never have to use C++ ever again, so it's fine. All right, did we break our... Oh. How did we... Oh, because we... Okay. See, here's the problem, is I just blindly put this is why you always test. I put this after this because I was like, oh, right after I allocate this thing, I want to put the information on the thing rather than storing it somewhere temporary. Well, guess what? I already parsed the right-hand side, like way up here. So I'm looking for these flags like way down in the wrong place. Okay. Like, this is kind of ugly, but okay, result operator type is this. Okay. Like, I don't know why I went through all the rigmarole that I did to make that token copy. Oh. Oh, that's why. Haha. Okay. Now, hey, we actually compile in the game. How do I remember what to do next in a big project like this one? That's no problem. There's so much to do. It doesn't matter. As long as you remember anything and then do it, it's fine. I mean, there's so many things. Any of them means progress. All right, so I'm going to go back to this thing. And I'm going to say shift modifiers That's going to be a function. And it's not, we're not going to test it yet because it doesn't work. Just checking that they parse for now. I don't know. I use too much cafe things. I don't know. Let's just do a boring number. Okay. Oh no, we want something with the high bit. High bit. OX chai latte. Somehow I don't think OX chai latte is a thing. How do you develop the workflow to the point you're this efficient? A, actually want to do the work. That is the number one thing. B, get rid of most of the development tools and environments and build steps. Minimize that, because all that stuff is garbage mostly. Not all of it, but you really don't want most of it. We already did Cafe Babe. Can't Battletoads. Yeah, okay. We're just going to do a boring number. Okay. B is a actually, we'll make that C. We'll go B is A, right shift 4, C. Because of all that pain in the ass that I just had today and yesterday in C++ from like, all I wanted to do is just shift without the sign extension. We should just make a way to do that. So we made a way to do that. It's not there yet, but you know. Okay. And then D is A no check 16, and then E is 36. The answer to this is, well, let's go 48. This is dependent. I don't know how you spell that. There we go. We're throwing a quick lambda in there. There we go. So we're not printing. All right. Shift modifiers. That's not right. Okay. So our problem is our format int what is the problem? I forget what the problem is here. Oh, the problem is that this any I need to put in an error for this, or a warning at least. This any that gets created here doesn't survive out to the outer stack frame. So say goodbye to the quick lambda. All right. Whoops, what did I do? Format? Why can I not type? All right. There we go. That's better. Okay, I wanted these to be 32 bits. There we go. Okay. You know, really, we're going to have to think about this when we go actually implement this for real. Because, like, I don't think this is going to say no check. This is going to be like no wrap or something. Because you still want a check. If you say that this shift is never going to be big, you actually in debug builds still want to generate a test that theory is correct. We can call it comma small. That's a little bit weird, but it's different from no whatever, which is sort of debug related. So marked as small. Whoops, I keep going to the wrong file. Small. Do you even lift? You look kind of small. What is my favorite C compiler? I don't have a favorite C compiler. Dude, I haven't run a C compiler. I actually ran the Microsoft C compiler for a little bit at the beginning of this project, but no, I don't have a favorite C compiler. I've been doing some work now to make sure it won't be such a pain to do when it's time to internationalize the compiler. No, it's easy. I mean, having done that with several games, I know what you need to do. And I probably just naturally don't do things that would make that hard. Would I recommend trying to make a compiler as a learning experience? If you want to, like if that's what interests you, the important thing is just to do a hard problem. Internationalized compilers are the worst. It's just stupid and makes looking up error hard. Well, I think to make looking up errors work better, I think you output the actual error code kind of like this, right? But I do see the point. I don't know. I kind of don't feel like everybody in the world should have to learn English. though, you know? No, that doesn't mean we change what the keywords are. Although that would be interesting to think about. But there's a big difference between having to know a few keywords and like not knowing the language that all these error messages are written in that are trying to tell you what's wrong. I mean, I could imagine as an internationalized compiler, if you want to help with searching for it, just print the errors in both languages, right? Print English and then the target language. It's like people just aren't even trying to solve these problems, you know? So you don't see any attempts. Parse modifiers for shift operations. They don't do anything yet. Bam. Check my tea. This is like the third steeping. Okay. Now, I was just doing that stuff we were just doing as like a warm-up. The most important thing to do before we make these actually work. Did I just check in? I must have. There we go. And the most important thing to do is to make the shift operations have consistent behavior at runtime now as they do at compile time and in constant expression evaluation. So we're going to do that. We're going to start with the x64. Here are our shifts. And we're going to just have a Boolean where we say bool skip. I'm going to call it small, right? So we're going to say if small, we do this. Else actually, let's say if not small, we do a preamble and a postamble, right? Why a postamble? Because we're going to have a frickin' branch target. Maybe that'll be, oh no, because the branch target will be here. I think it's actually, we may not need this. Okay, right? So if we're not small, we have to do something. And what is that thing? Well, we need to know how big is this quantity. We're going to get the auto bits again. We're going to say auto bits is register size, register A, right? Times 8. And then we need to write some machine code that says, because remember, we don't know this is a totally live value. Kind of. Okay. We might actually get here for constant width shifts where the variable on the left is unknown, which honestly is probably a majority of shifts. The problem is we have no way from here to know that this is constant because our intermediate representation just evaluated the expression, assigned that to a virtual register. So this could be constant a lot of the time. So we're going to generate this check even for constant small shifts right now. Later, we're going to want to mark that because we know it's a fixed size shift. And actually, I should put that on the list. Since we're doing bit shift stuff lately. Because even if you don't have to, even regardless of these issues about whether you output this check or not, just in terms of number of cycles, the instruction to do a fixed shift, certainly on x64 and maybe on other CPUs, is a lot faster than the instruction to do a variable shift. So right now, we're paying more than we should. Check my T. It's all right. I think, you know, maybe it's the Reese's Pieces making it taste weird. Yeah, it's weird how languages shake out. Like, English kind of became, through historical accident, basically the Dutch made English the international language. And the only, I mean, currently you might think, well, there's so many people who speak Chinese that Chinese might. But like, first of all, there's several Chineses, right? So it has to have to be Mandarin with simplified alphabet. And second, Mandarin with simplified alphabet is way harder to learn than English. So like, good luck with that. Spanish probably is the global leader in terms of number of people who speak it. Maybe. I don't know. I mean, a lot of people in Africa speak English, you know. Like when I went to Sub-Saharan Africa, when I went to Sub-Saharan Africa in 2002, a lot of people spoke English. Like today, it's got to be over the top. A lot of people speak primary school English, doesn't mean it's functional. No, it is like, okay, different parts of the world are different, right? But like in Africa, for example, what you had before colonists showed up was like a lot of groups of people who all had their own language. And a lot of them didn't really write, as far as I know. In sub-Saharan Africa, right? Northern Africa is a different story. I guess they had, I mean, they must have had writing. They just, I think it just wasn't in common use by the common person, right? And so you didn't, so after, and then of course you have really, really bad situation involving colonization for a while, right? And then by the time colonists leave a lot of these countries, what you've got is a larger group of people who didn't necessarily have as much in common with each other historically or culturally as you would assume, right? Because it wasn't as I don't know what the term is, but like that area, it's not like that area had congealed into large nation states and then colonists took it over. It's like, no, actually, a big part of the reason colonists were able to invade Africa is because it wasn't like that. Or, again, sub-Saharan Africa. Anyway, so the point being that once some of these, once the colonists leave, it's like, it's not like that there's a language that everybody across sub-Saharan Africa used to speak that they can now go back to speaking. You know what I mean? And that makes things more difficult and more weird than it would have been otherwise, right? All right. Let's go back to programming. Okay, so we want to know if RCX is bigger than some value, is there a good way in x64 to just cap a number? Like saturate, yeah. If I want to saturate this number, because what we did with sign shifting earlier today is we said, look, if it's bigger than the word size, blah, blah, blah. If you're capping on a graded power of 2 boundary, we're not. And the whole point, no, you can't use bitmask because that's not a saturation. You want to get into computer graphics rendering? Is that a good path? Yeah, sounds like a good path. So, CMove, yeah, I mean, maybe. Let's do the compare. Okay. So, we're going to compare RCX to a constant. Now, normally I would be super lazy and load a thing into our register because I don't think we have a compare to constant. We have compare with 0. Okay. So we're going to compare with constant of RCX against bits minus 1 with, I mean, this number could be up to 63. I think a 1 byte constant, let's keep our naming convention. I think a 1 byte constant is fine. Let's use our same. So this is a U8. That's a thing that we're going to want to do. Okay. So now we get to look up compare. Didn't we have? Okay, so we have this page open. Index. So the problem is there's going to be a ton of compares. Let's just try to find CMP. Compare two operands. Okay. Immediate 8. Compare AL versus immediate 8. I mean, we could do that. We could put it. We could swap our stuff around. Oh no, because we need CL for this. Ugh. Like, oh my God, guys. Okay. So we're going to compare mod RM 3, comma 7. Okay, here's how I think this goes. We need the RexW because we're assuming this is 64-bit. This is a whole thing where later we could generate a smaller thing, whatever. But right now, we're extending everything to 64-bit, so we don't have to think about any of this stuff. It makes for inefficient machine code, but that's just what we're doing. Mildly inefficient machine code. Okay, so RexW 80. What about these down here? Oh, wait, right. We want this one. RM64. It's been a while since I've looked at these. So we want RexW 83/7 immediate byte. 83/7. That's the same as this. Oh, this is This is the same thing. I just put a 0 immediate byte in there. Are you kidding me? All right, that's fine. Okay. That was easy. Okay. Hard coding x86 operand seems like a crappy idea, but C++ doesn't really give you a way to compile time. Look from a file of identifier integer pairs? What? How would that help you? That would not help you at all. You may be thinking that machine code on x64 is more straightforward than it actually is. I don't know. Is this the Dungeon Warfare 2 waiting room? Quite possibly. If we feel good about how much work we get done today, then yes. Okay. So we're going to compare and we're going to do a jump. And of course, okay, we're going to do this. We're just going to hard code it. So what's going to happen is we're going to need to branch, actually, it's fine. Just going to do this in here. We do a jump if above. We don't know the address to target yet. But we will down here. Okay. Yeah. So let's just do it this way. So we're going to do some stuff. You know what? target A is output.length. Post branch A. I should make a more shorthand way of doing all this, but there we go. So we're going to do some stuff in here. Well, what are we going to do? We're going to go if the shift size is less than bits minus 1, less than or equal to, is less than bits, I don't know, less than or equal to bits minus, it doesn't matter, we have compares for all those. If the shift size is that, then set it to bits minus 1. Okay. So we're going to do a branch. I could do a C move. It's just I've heard C moves are not actually good. Like CPUs don't really like C moves that much. They'd rather have branches, as crazy as that is. Okay. So once we have branch A distance, okay, because this is a relative jump. All we're doing here, if this is confusing, all we're doing here is we're going to do a jump and then we do the jump. And then we're going to jump to some, before this instruction, whatever this is, right? Yeah. Okay. Man, I just can't get the temperature right today. Side of the window's got to be open or it's got to be closed. And then noise coming in from outside. Okay. So, well, what goes here? Easy, we want to assign to a constant. And this detects the size of our constant. We actually So that'll work. It's just going to generate a bigger instruction than we want. I should make these jumps return a struct. Or like fill in a struct that has this and this. And then we call something down here to just do this stuff. So I don't have to remember this all the time. What was the issue I had with CMove? So I don't understand this issue very well, but when processors speculatively execute for some reason, the condition part of CMove is not as easy to predict or make a table for or something, as opposed to the branch prediction, which CPUs can do. I don't have a clear picture of why that is. It's just I've heard it multiple times from different people. I don't understand why in principle it's any different. Because a CMove is sort of just a branch around its own instruction. So why is that different? I don't know, but you know what? Let's do a CMove. Because I don't think I've done CMoves at all. And like, regardless of whether it's faster or not, we're not really trying to generate the fastest code in the universe anyway. And it would be fun for me to get some CMove experience. Right? Conditional move. Okay. Move if... So let's see if the codes are the same. 7.7. Is there a 7.7? No. Of course, the codes are different. And of course, I don't remember what these flags mean. Carry flag and zero flag. So above means strictly greater for an unsigned number. And greater is for signed numbers. Yeah. Okay. We want a CMove of R64 RM8. Maybe they don't have that. Okay, so this kind of sucks. Well, there's no immediate. Okay, hold on. Here, there's no CMove immediate. All right, well, whatever. Rip the CMove idea. All right. So, well, Let's double check this. JCC relative 8. Move immediate into register. I mean, I guess. I mean, what's so funny about this is we know how big this is going to be for now, so we could hard code this and not do any of this other nonsense. The problem is we're going to go change this function later and blah, blah, blah. But the weird thing is this has a performance impact. So our compiler would be faster if we just put the number there. And it's like, what are you going to do about that? What are you going to do about that? There are things you can do about that, and I will consider them later. But, oh, small is a word that this, oh, God. Okay. Bits is skipped by case label because we are in C++. So of course you can't just write code, you have to put braces. It's C++. C++. Seems like the experimental conclusion with CMove on KCStream. Yeah, you know, I was excited about CMove when they first announced it, but it doesn't seem like the play. All right. Is this going to work? Probably not. Oh, that's the wrong backend anyway. Okay, so our code generation didn't crash, which is great. But what about this? We got our -1, right? So if I make the LLVM backend, that gets this one wrong, and we got this right. -1, 0, 0, 0, 14, 7. LLVM gets them all wrong except the easy ones. So that's great. So that's our right shift. For left shift, we have to do something different. Isn't it great when it just works the first time? You do all this crazy stuff. Okay. I almost... Let's do this. Before we keep spreading this stuff around and making our code more and more heinous, we're going to say... we're going to do this. And we're going to do this. And then down here, we're going to go that. And we're going to get rid of all these things. Throw these down here for a second. Like, that's just more readable to me. inline void branch target concatenator C branch 8 branch target minus branch arrow post instruction position target byte is distance. All right, well, what's branch 8? Struct branch 8 has int post instruction position and S8 target byte. Okay. Wait, we lost the compare. Okay, that goes there. We don't want to get rid of the compare. All right. So now we want to make a version of JCC relative 8. Okay? And that is going to be okay, we're not going to return anything here. And wait, what? Did I remove my entire jump? What am I must have copy and pasted that. I hope. Okay, hope I didn't delete some random line from the compiler. What did I call this? Target byte. Let's put this at the top. Target byte equals this. And then branch arrow post instruction position is C dot length. Boom. Much nicer, much nicer. Except that it doesn't compile. Not nicer. Oh, variable names. Output. Branch 8 followed by int is illegal. Where? Oh, this. C++ problems. $871. More C++ problems. Hey, we're building now. We're building. All right, great. Whoops, wrong backend. There we go. Hey, there we go. This appears to be right. So the non-constant shift that we're getting wrong is the right shift, right? So we're getting wrong currently C. Oh wait, no, that's a left shift. D we're getting right. So wait, why are we getting B correct? We didn't put anything in for that. Why are we... I don't understand that, but okay. So this one, the right shift, these two, our new code is kicking in. Because we just did right shift. A and D. All right. So now let's do the same thing. So we cleaned this up. Now we're going to do a not small here. If it's not small, whoops, we wanted greater than, yeah, whatever. If the shift size if the shift size is greater than or equal to bits, set RCX to 0. All right, we're just doing the same thing we did yesterday in our actual code, right? Okay. So we want, let's go back to the JCC page, the Jewish Community Center in Berkeley, I think. JCC. We want above or equal OX73. Jump if above or equal, and wait, what? We did the wrong thing. How is this even working? I must have the operands in the wrong order. Okay. For the way that I'm thinking about this, I want to compare. Okay. This is comparing bits minus 1 to RCX. Wait, what? Which direction is, because I was like, wait, this should be below for this to do the right thing. I think this is saying if bits minus 1 is greater than RCX, my brain doesn't want to think about it in this direction. If bits minus 1 is greater than RCX, then don't we're going to have to change. My brain just won't do it. Okay, hold on. Let's go back to this compare so that we're not guessing. I want to know. So what does this mean? This is basically the greater than sign or whatever goes where the word with is. But we could swap it around. What is this karma garbage? Do we have to ban Instabot again? Okay. Immediate is always on the right of the operator. Okay. Then why did this appear to work? So then we're saying, is RCX greater than bits minus 1? If so, jump. That's not right. We want jump if, you know what, I probably have it in here. Jump if below or equal. Right? If RCX is less than or equal to bits minus 1, we go to the branch target. Otherwise, we set RCX to bits minus 1. How did that work before with the jump completely backwards? Okay. So we're going to do the same thing here. We're going to compare it with bits. So we have a JB. This is JBE, by the way. See, I put JB there, but that's JBE. All right. Well, okay, now we have to double check this, actually. Because maybe oh God. See, you do that, and then you're like, oh wait, it was the other part that was wrong. JBE is 7.6, okay. 7.6, jump if below or equal, great. What do we want here? We want, again, jump if below or equal. And do the branch. And then why can I not type? So, okay, see, we do this and then we do the thing. You know, we don't need that. If it's not small, branch target. Okay. Wait, I left this branch target in from before. Wait, okay. You know what, this is, okay, this is stupid. Let's just do this. Because this part is so easy right now. We're just going to do that. And we're going to do that. We're going to keep it in the family. The actual shift but the what am I Okay, right. So we just jump over the shift, right? Wait, no. Why am I so stupid? My brain isn't working. We need 2 jumps, right? Because like, what a pain. Okay. I keep restructuring in my head the way we want to do this. Let's just, because we're stupid, let's do this no matter what. We'll do this branch target here. And what we're going to do, if we fail the branch target, we're just going to 0 RAX. We still end up shifting it below, but we are shifting 0. So what are you gonna do? Right, and okay. All right, 0. There we go. That's all. So we're just saying if you're shifting by, we don't want JBE unless this is bits minus 1, then it's fine. Okay. That's fine. I could put the branch target out here. Who cares? It's slightly more complicated. Okay. Output. Why not a conditional move? We just went through that. It's like annoying. And probably not fast anyway. All right. Now our code is upset with us. Oh, because we took this out. When I swap this with this, ha ha, ha ha. Okay. Boom, boom. Well, now we get all the non-constant shifts right. I have no idea how we got it right when our jump was backwards. That's a brain teaser for the audience. I'm going to warm up some more tea. Are there any on-topic questions for what we are doing right now? Any questions about what the hell is going on with regard to bit shifting? I'm going to have to dump the old tea out of the teapot. Will you provide a hint that you can give the compiler guarantee that the shift is small? Yes, we will do that. Can you shift by negative amounts? No, you cannot. Can you give a quick 3-sentence description of what is going on? In languages such as C and C++, you have operators to shift integers left or right by a certain amount. The problem is that way back in history, CPUs had different ways of handling what it meant to shift something by more than the size of the machine word. And especially Intel chips made a very unfortunate choice there, but they can't fix that for backward compatibility reasons. So, I mean, they could just add new shift instructions, I guess, but they're... You didn't see any code to handle the logical shift right correctly, which would result in 0. Anyway, to finish the explanation, so old languages like C and C++, because C++ inherits problems from 1970, just said, look, different computer, well, okay, C said, look, different computers just handle this differently. If you're a programmer, you know that, whatever. Later people perverted that into undefined behavior means the compiler can do whatever it wants. And so it's very, very dangerous now to have basic operators with these semantics. It means programs are full of bugs and compilers will freak out and do bizarre things with them, right? And so the right thing to do if you're making a programming language that doesn't have that kind of unexpected, well, first of all, your compiler shouldn't try to use those things as an excuse to freak out. But secondly, you shouldn't have those things in your language at all, right? So having a fundamental integer operator with undefined behavior is inappropriate for a high quality programming language in the year 2020. And many of the other people making programming languages would agree with me on that 100%. Like, that is not a controversial statement. It's absurd that C++ people think, the quote modern C++ people think that they have some kind of nice advanced language when it's got all these holes. It's like your boat's sinking through all the water coming out the bottom, but you're just looking over the top of the boat going like, oh, everything's great. Are bit operations on signed integers allowed? Yes. Numbers are 2's complement in this programming language. That's just how it works. You didn't see any code to handle large logical shift right. I just did that. So, okay. Here's the trick. Oh, no, you're right. You're right. Okay. I forgot. You are correct. So the case that is not right is this one. Because this trick that I do is for arithmetic. Like, really what should be is this should be in here. And then this one should be there. And we're just going to cut and paste. And so we're going to make this one dense because it's really not that much. This is a small amount of code. We're just going to label that as a paste. Right? So now, okay, if we're doing a logical shift right, so this high bit trick that we're doing here only works for arithmetic shift. It doesn't work for logical shift. Because you'll end up with a 1 in the low bit if you do this with something with a 1 in the high bit. Good catch. Thank you. Somebody was paying attention to what's going on. Wonder if you could point me a starting point to get into low-level programming. Play the Zachtronics games like TIS 100 or Shenzhen IO or something. Those are way better than other things. All right. Any more on-topic questions? I'm going to go swap out the tea for a new tea. What's up? No questions, I guess. No questions. Well, nobody cares. All right. So now, the least fun part of the day is we have to make LLVM do this. Question. Does LLVM already have this facility in there because like every reasonable programming language wants this? Or do we have to generate it ourselves? Also, when I changed JB to JBE, there was a JL nearby. Aha, that one. Cut and paste errors. Let's check this in. Okay, let's just, before we do the LLVM Fiesta, we'll check this in. Oh, let's finish the thing that we're doing. So with this one, I had that outside for historical reasons. All right. So, does it still work here? Yep. Does the game compile? Yep. Does it run? Let me, I got some T grinds in the bottom of my thing here. Okay, gonna run the tests. About most Win32 API functions? Pff, talk about Linux functions, man. Oh my God. Okay. Well, Visual C++ is telling me all these things are wrong, but they look right to me. So what do you want? x64 backend handles shift operator clamping. Bam. Okay. Next. This is where I get grumpy. Okay. It is currently just a create shul. Look how few lines of code it is and what it's about to turn into. This is the worst, like, okay, if anyone else out there ever makes a compiler framework like LLVM and you want it to be the #1 thing and all over the internet, do not flood the internet with garbage non-documentation that nobody can use at all and have that be what people see when they search for your thing. Like, this is so bad. Okay. What are has New South Wales? I don't know. Guess what? If this were actual documentation, it would tell me what those things mean. It doesn't. It is generated, yes. This is Doxygen, which is a garbage documentation generation program. Okay, let me just search on the create shul has no. And like now I have to search through all this. Like, these are all copies of the same garbage. Like, literally the entire first page is just Doxa garbage. Why does anybody think this is a good idea? I don't even know what I'm looking at here, but it uses this string. No unsigned wrap. But it's not. Okay. But it's not actually producing a consistent answer. It's not doing, like, there's no mechanism to say, give me a CPU independent result. This is just like a, I don't even know what. Is this like for UB-SAN or something? Like, If you pass true, it adds more UB. Wait, what? I don't understand at all. It looks to me like I just actually have to do this manually, and I'm just going to ignore these parameters. They don't want me to use these parameters because they didn't document them, so that's fine. For example, int min. Oh, okay. So no signed wrap doesn't mean this is known not to create signed wrap. It's the opposite. It says don't allow signed wrap. Right? Am I interpreting that correctly? This is saying LLVM, I would like you to consider wrapping an integer in this case to be an error. Or like for bits to shift up the end. No signed wrap means this instruction is known to never wrap in a signed manner. Well, that's stupid. That's just a very C-centric thing. All right, this is useless. LLVM, what would I search for people who have done this and maybe found a better way than I'm about to do? LLVM shift by word size. I don't see anything helpful. Probably you want to use a select instruction, which takes a condition and two values to produce. Okay? So it's basically, it's an expression if, right? So we say if this, then A, else B, but it's like, it's functional and I don't have to omit all the branches. That sounds like the right thing. Okay, so do we do this? Selection. I don't see the word select. So let me look. LLVM selection function. We don't want instruction selection. We want a select instruction. Select instruction. Okay, here we go. Select instruction is used to choose or you lose. It's used to choose one value based on a condition without branching. Okay, how do I actually create this through the API? Create select inst. Create select. I actually guessed it correctly. Create select. No, that's a no fold. What? Fold. What? That's not right. Select inst create. How do I get a... Do I say colon create? I guess so. Okay. Okay, so if we're just going to do shift left, which is the easy one, I'm going to say cell equals select inst : create with some things. Condition let's just call this op, right? S1, S2, insert at end. There's no optional arguments for these. Left, shift, no, I don't know. Hello, Lana people. Is it very bad that I noticed from the toilet paper icon whose stream it was? Sorry it took me so long to notice. I've just been staring at this thing. Oh, create select. Oh, it does have our default arguments. Okay. We'll just do that. Can you have a variable called else? Else is not a key. Oh, no, you can't. Switching around too much between programming languages. Okay. All right. We want to create like an assignment. I could just XOR it with itself. That's in classic. I mean, do I add sugar? I don't very often do sugar in tea. I do honey sometimes. This is the same thing as useless oxygen. Welcome all you people to the place where we are doing compiler things. CMove is almost always faster. I will read that. I'm not sure that I believe that because smart people have told me that it's not the case, but I'll read it later when I have time. Okay, so we're doing shift left here. So we need our condition is going to be wait, should I be? Why am I calling IR builder create for these, but then select inst? Is this going to hose us? Because we're like we're being threaded and stuff. Do I need like IR builder create select? Is that a thing? Because there's always got to be multiple ways to do everything. Let's just put garbage in here for a second, see if it compiles. Oh, it takes so long. It actually, okay, that is a thing. All right, great. Okay, so cond Put an underscore for consistency. Yeah. Cond is, well, we want to do some kind of create something to see if cast A is greater than bits. Wait, we're doing left shift, bits minus 1. What's bits? Well, what do we have available here? Auto bits is register size. BC index A times 8. Okay, so we need to, like, instead of XOR, use IRBuilder getInt64. But it's not getInt64. It's like, oh, this isn't right. Okay, I actually want to 0 this value. This is not doing that. This is going to XOR with itself and make a 0, but I actually want to set it to 0. Create iCompULE. Create iCompULE. Unsigned less than or equal. And iComp means integer compare, right? This is the opposite, though. So I want UG. If it's greater, set it to 0. Otherwise, do the shift, right? UGT. Okay. You have to use the output of the select instead. Wait, what? Right. How do I... Oh, right. Yeah, we don't want to... Sorry. So, yeah, you're right. I just confused myself. So getInt64 is the right thing. Right. Of course, we don't want to assign... Okay. See, I was thinking back, confusing myself by thinking back to the specific implementation of the x64, where I was using register A to, like, hold the thing. That's not what's going on. This is a totally different situation. Wait, I deleted the wrong thing. There. Okay. Much better. So if we're greater than bits minus 1, set us to 0. Otherwise, shift left. And then that select is our thing. And if that's right, oh, geez. So we don't have these functions available here. Okay. Do that. Okay, now we're getting complaints. IR builder cannot convert argument 2 of icomp UGT. Oh, because we have to create a constant. Get int 64. Can I like make that 8 bits? Is this going to freak out that this is 8 bits and this is 64? Probably, right? Maybe not. Maybe it'll freak out at runtime. Like LLVM seems very tweaky about that kind of thing, at least in the past. Cannot emit physreg copy instr. Yeah, like, okay, let's make it 64. Hold on. Even that, I don't think we're allowed to do 64 bits here, right? Like, we have to make them the size of the input register. Right? Otherwise, LLVM will freak out. Both sides of shift. Wait, both sides of shift have to be the same width. Okay, that's actually fine. That's nuts. That doesn't make any sense, but okay. But no, it's just that that's not what I'm worried about. What I'm saying is so first of all, okay, the output type of this select has to be the output type of the variable that was inputting into the shift, right? So this getInt 64 is not, it has to be getInt of whatever size the input variable is, and same with this. And so I need to I don't know how to do that. I don't run the module verifier that would spend extra time to detect those problems. Well, that might be compiled in, or it's just we don't want this to be any slower than it already is. Verifier. I mean, there's a verifier.h. Okay, so if we're in debug mode, we do, I guess. But yeah, when we actually ship the compiler to people, we don't want it to be any slower than it already is. Doesn't false mean no verifier? I don't know. Why would you call create verifier pass with no verifier? Maybe this was just there for like Josh to turn it on and off. I don't know. I'm not going to worry about it because I know what's wrong here. Okay, so I need to get the type of, yeah, what you're saying. I need to get the type of A. Right? Yes. So I can do that for bits. Thank you. This is saving me like an hour, by the way. Except I can't use constant int get, right? Because I have to use this IR builder interface. So is it like IR? Is it like IR builder create constant int or something? Like that? You don't need to use IR Builder for constants. Okay, I'm gonna say in Twitch chat said, because I'm gonna capitalize. I'm gonna properly punctuate your sentence. Okay. Well, I don't know why that is, but I'll just believe that and do this. Okay. So the condition is going to be Boolean. Clearly, this is going to be the type of A. That's probably the type of A because it's a shift. All right. Okay. All right. Let's see if we get a horrible error, and then you have to go to debug mode. Let's not do tests yet. Let's do this. All right, that's okay. This is compile time execution. All right. Well, we got the left shifts correct. Including, so this is a left shift, a small left shift, right? E. Yeah, that's a left shift by 1. So in that case, we had to go through the other branch of the selector. All right, thanks for teaching me about the select instruction, because that's going to be useful all over the place. And it appears we didn't use that before. So I don't know if Josh was doing manual jumps or something. I don't know. He might have been transcribing in the early days what I did in the x64 backend over to LLVM language. I don't know. For reference, IR Builder get int32 just calls constant int get, but you don't have to pass a context explicitly. Whereas IR Builder build whatever actually does useful things. Do you mean create? Yeah, you know way more about LLVM than me, I'll tell you that. Okay. So shift left is the easy one. Shift right is annoying. What did we call it? Well, we don't want that. So again, just like we did in x64, for logical shift, we're going to do the same thing, except it's not exactly a cut and paste because this is different. Okay. And then in the signed version, I guess we'll do our same trick. I was thinking, would it be better to do it a different way, but no. Okay. So we get our bits. So here we're going to make a selector that just changes the shift amount. Like, is there a max function in LLVM, or a min, actually? right? If I can say min on shift B, okay, I'm going to say limit is constant int get cast B get type bits -1. Okay, that is the biggest shift. So now I want to say auto shift amount is whatever, like the min of cast B and limit, right? And then we do shift amount. So how do I do min? There's no integer min, you have to use select. Okay, that's fine. That's fine because we know how to do that now. Okay, so shift amount is select cond, then an else. All right. I mean, so this is just going to be cast B or limit, right? We're going to get either of those, and that's going to be the shift amount, and then we're going to shift by that shift amount. Okay, what is the cond? The cond is cast B greater than, or no, less than limit? Right? So if cast B is less than limit, cast B, otherwise limit. Create. Right? It's so good that you happen to be here when I'm doing LLVM things. I haven't done LLVM thing. Well, I did some yesterday or whatever, but not significant amount. The thing I did yesterday was just this, which was very easy. Because that is just, it was a little bit annoying because it's not, you would think that there would be a create rotate, and there's not. You have to like call an intrinsic or whatever, so it's different, but yeah. Okay. That compiled, and we got it right. We are winning. We are 100% winning. So all of our backends now get the right answers as far as I know. So we can re-enable these asserts. You know what we might do? We might have a Happy Miller time where we play some Dungeon Warfare, and then later tonight we might do a third programming stream. You know? This is great. Okay, so let's make sure we didn't break the game. We're going to compile the game with the LLVM backend, because we could have easily messed something up. Oh, see? See? Okay, now the question is, I haven't actually tried compiling with the LLVM backend in a while, so like, yeah. All right, first, let's just look it over. If we don't see anything obviously wrong, we can, my first step would be to just back these out just for a second with the old code and like make sure that that's the problem. Because the problem could be it's been a little bit since I did the LLVM backend. So the problem might not even be here, right? But let's again look. the bits is the size of register A. We put that in the type of B. We say unsigned comparison of less than. If B is less than limit, then we pick B. Otherwise, we pick limit. Wait, that's not right. Oh, yes, it is. For arithmetic, yes, it is. Boom, arithmetic shift right by shift amount. That seems correct. Okay, if we're greater than, if A is greater than bits minus 1, then we put a 0. Otherwise, we put A shifted left by B. That seems right. And this is the correct shift. Arithmetic shift right, logical shift right, shift left. There's no arithmetic shift left. That's not a thing. Okay, the bits, like this is the thing that I'm worried about. This is the thing that maybe looks the most wrong to me. How do I get the size of a type in LLVM? How do I find the size of a type? Stack Overflow. That's the first answer. If you only need the size, you can use get element point. What? Okay, this is like not even get size in bits. Okay, that's, see, you know more than Stack Overflow. All right. So this is better because there's no, like, I saw this code somewhere else and it's like indexing this, but I don't know that that's the right indexing because this is like offset. I don't know. It's confusing. So let's just do get size in bits. See, LLVM at least has good naming. Like get size in bits is appropriately named because it removes the ambiguity about what's the units of size. I don't think that's going to actually fix anything. Get size in bits is not. Oh, I don't know. I don't know. Get integer bit width. That's equally good. It's a little long, honestly. All right. I feel like this is still going to crash the same way. We'll see. Yep, very quickly. Okay, so here's what I'm going to do. I'm going to roll it back for a second. I'm not actually going to, oh, let's go to LLVM converter. And we're going to diff. And I'm just diffing because this used to be very, very simple, right? So I'm just going to copy these. And I'm going to go back here. And I'm going to do this. And I'm going to comment these out. All right? So. And then if that works, I could comment in one of them, right? And then comment in the other one. All right. So we're back to the old shift operators. And it works. Okay, so now there could be many things wrong here. Okay, for example, might not even be a bug in the code we just wrote, right? Because maybe the game was doing something invalid with bit shifts, and now we've changed the result of that, right? Although it doesn't, like it works in x64. Whoops. It works in x64, so that's actually not likely because we changed it in x64 also. But it's like, it doesn't necessarily mean that this is the problem. Okay, so shift left is simpler, so we're gonna put that one in. And maybe if this dies, like it's possible that the verifier pass would like find something to complain about. Okay, well, let's try the other one. Expand feature. Okay, we at least, let me just look. Table type. Read to from offset. I mean, this is not a left shift, right? So I'm not actually sure. It's like, it's probably like this right here. Now what's weird is these are all pretty straightforward. Now I suspect that if that crashes, right shift will also crash. Because wait, what? Guys, hold on. Okay, old right, new left is what we have right now. And that's what crashed. So we're going back to, whoops. We're going to go old left, new right. New right. Old left. This probably crashes as well, in my opinion. Reference the generic way is DL get type size in bits if you don't know whether it is an integer. Okay. We'll put that in the code too, because we might want to know that someday. Okay. This is going to crash, right? Yep. Okay, so something is going wrong. So the next step, why do we still have a window open? That bothers me. Okay, now closed. All right, let's close this. Like, which of these is the wrong? We're gonna please close Windows. It's too many. Yes. Yes, I want to close the tabs. All right. So we were looking at this verifier pass. Let's look that up and see the garbage oxygen. Oh, fatal errors. It doesn't say what that means exactly. We're just going to do that in release build. Yeah, I don't know where to look besides Doxygen, because like llvm.org didn't seem to have the right kind of information that I want to know. And when I search, I just see Doxygen everywhere. So like, I don't know what to do about that. Okay. The verifier pass didn't say anything, I think. Let's try it. We'll leave this old thing and we'll just say, I'm just going to say true. Try it again. Trying it again. I suspect our types are fine. Load font again. That's weird because so we got a 0 back. I don't think we do reversed. Oh, we're in read 2 from offset. I see. So we're in my swap 2. Okay, this has a right shift and a left shift. And we're actually, so this probably got inlined, right? Because it says inline and it probably did that. So no wonder we're crashing in the same place. The question is, I never remember where the right windows are. Windows. Oh, no, wrong one, wrong one. That was also just a really intelligent window choice right there. This one. Okay, I don't think we need our assembly to be a giant. Okay. Wow, this is wait, what? This isn't right. What am I even looking at? What? I'm just looking at these instructions like before we even RCX reads out of base. Wait, what line of code are we even at? This is... Dude, I don't even know. Read to from offset. What is happening here? I guess these are, okay, never mind. These are stack locations. Okay, I get you. I get you. I get you. I get you. We're adding, okay, I get it. I get it. So this is just this. We put that, this is just doing what my frickin' thing does. Are we sure this is LLVM output? I think it is. All right. Okay. So base offset, that is now in minus 48H. If reversed, I guess we're saying it is, because we're calling my swap 2. Okay, that's fine. That's inlined here, I guess. Okay, so RAX is, this is probably the constant for 8, right? Adding some giant number. Oh no, this is, okay, this is global data, right? This is offset into global data. This is loading this pointer, pulling DX from there. Let's just find the shift. I don't know, guys. Except wait, we crashed here. There's not even a shift anywhere. Does anyone see a bit shift? Of any kind? There should be a right shift and a left shift. I kind of feel like that select didn't do what it's advertised, because there shouldn't be. Okay, let's get rid of this verifier pass stuff that didn't help us. Like, okay, when we get here, we're either doing an arithmetic shift or a logical shift. Those instructions have to be there, and they're not. Wait, except, okay, never mind. I assumed my swap 2 was inlined, but it's not. Okay, never mind, because there's a call to it down here. So all this is just setting up for that call. So like this thing where we're crashing, Error? What do you mean error reading register value? What? What do you mean error reading register value? Oh, it's because it's in a different frame, I guess. Oh my God. So the problem is this could well be an invalid pointer from like somewhere. And that doesn't actually help us. So okay. This is one of these things where I start debugging and then I look for the shift and it's like somehow my attention is being drawn to the wrong place, right? So the input here, like base, I mean, this looks fine. This looks fine. That looks fine. What? Unsigned short star. I mean, I can read that memory location. So why is LLVM freaking out? Okay, that's the same. See this value here, this RBP minus 48H is what should be an RCX that it can't tell me, right? And we're trying to move that into D. It's fine. Like, why is it crashing? I don't understand. Is it actually crashing or are they just confused and not showing the right place? That could be. That could be. It's a pointer RBP minus 48H, isn't it? I don't know. I mean, what do you mean? Like, that's pretty straightforward, isn't it? Set a breakpoint in assembly in single step. Okay, we can try that. The problem is, I don't know if this is like the first call to this function or the 375th. So we will try this, and if it doesn't work, we could printf debug or something. Right. You can't do assembly breakpoints in Visual Studio anymore for some reason. Like I can't. Thanks. Oh, okay. So do we crash here? No. Do we crash here? No. Yeah, like, let's see if it's a reasonably steppable number of times. Let's get rid of that one. It's a lot of times. Wait, are these values changing? Yeah, the offset is changing. Disable breakpoint. Well, now it's crashing up here, though. I don't know, people. RCX is pointing at RBP minus 48. No. No, it's loading, right? The brackets mean grab the value that is stored in this memory address, right? This is a dereference. So RCX here is the same value that was just stored from RCX here, because base pointer ain't moving. So like RCX, we load. Wait, why is this EDX now? Oh, because it's swap 4. It's the same code, slightly different. Okay, this is actually telling us RCX this time, though. Okay, it is pointing at invalid memory. Why? Why? Offset is a pretty big number. 148304. How? Like, have we just been reading off the end the whole time and it just worked and then now it somehow doesn't work? Or did we change our idea of how much data there is? Let's see. Is feature list table, what do we? Feature list table. All right. Okay, so normally we would have this be a string. This was ported from C++ where we didn't have native strings that are bounce checked. And so, yeah, okay, when do we load this and how do we know how long it is? Buffer plus feature offset. Feature offset 0. Okay, I'm not sure if I like that, but where does that happen? Oh, right there. Script offset. Okay, this is broken. I think, I mean, I don't know, but I think those numbers don't look good to me. Okay, how long is the buffer? 22K. So we're reading 148K. Well, hold on. Yeah, we're reading 148K into a 22K buffer. So that's not good. Well, you know what? Here's the thing. if this read to from offset is broken, we can just copy that code exactly into a smaller program. Let's go weapons hot on our new implementation here. We're going to comment out the old one. Maybe it's far-fetched, but when you implemented the bytecode instruction where you had already used the same one with a 0 constant, there was an inline macro call in the instruction which was mismatching the one in the original instruction. I have no idea what you're saying. No idea what you're saying. Okay. Font. So we're going to do this. And we're going to paste this into our little program that we've been doing here. Right? And we're going to go S, A, A, B, B, C, C, D, D, E, E, F, F, right? And red is read to from offset s.data. Print red is whatever. So data 0, it's false, I guess. Oh, true. I don't know. Oh, now it's complaining. Wait, what? It's complaining about rotates. That's not even what we're working on right now. Oh, wait. No, I thought for a second, what if I forget our breaks? Intrinsic name not mangled correctly for type arguments. Should be LVM Fusher I32. I32. I don't, that's not even what we're working on, but okay. See, it doesn't tell me what it actually is. It's like, let's not tell you what you passed. Or maybe it did. Maybe this cryptic notation. What the hell does this mean? I mean, I call cast A, cast A, cast B, and I say get declaration, cast A, cast A, cast B. What? I don't know why that's wrong. You can fix it. Uh-oh. I don't understand why it's wrong. Yeah, that's what I'm thinking is there could have been broken rotates way earlier, right? Yes. Because all the stuff that gets those offsets is all reading byte reverse things out of this buffer. So should be cast A, get type. You mean around each of these separately? And then it's varargs or what? Just the first one. So that, and then no more? That doesn't make sense. But you're telling me to do this. All the args are already known to be the same type, so you only need to pass one. But like, why is it bad to pass more? I mean, the thing's got 3 arguments. All right. Do not question the ways of LLVM. All right, so it didn't complain that time. Okay, well, this is broken. We read 0 out of our thing. So that's not good. But, well, so let's try that. Mem is 4141. I mean, it's either going to be 0 or not. A is 0. So like this simple right shift is producing 0, which means this select is busted, right? Here's what I'm going to do. I'm going to start debugging. Well, I'd have to comment out the rest of the program, but like I could just start saying, well, return bits. Let's see what this is, right? And see it in the output of the program. Intrinsics are overloaded somewhat arbitrarily, so you'd have to look up which args to pass. Great. What does x64 say about A? It's probably right, but let's see. There we go. See, my back end is better than LLVM. Well, not really. It's that this is not right in some way. So it's really obvious and you're an idiot for not noticing, okay? I was going to say I can start debugging by seeing if we're hitting the then clause all the time by putting like 42 here. And that'll give me information. Of course, we'll probably assert on these not being 0. Yeah, because let's take those out for a second. Using cond based on A, but B is the shift amount. You know what? If you want to succeed in the game industry, then know the difference between the shift amount and the value that you are shifting. So we did it right up here. No, we didn't do it right here. Okay, now to be fair, if these were not called A and B, it would have been easier to spot, probably. But like this is a generic handler for all binary operators, so it's like hard to have a more specific name. But also, so that part is sort of my fault. But LLVM's fault is that like once stuff looks like this, of course you can't tell what's going on, right? Like, ugh. That might not be the only bug, by the way. Who knows? Let's look. But also, though, I did look it over, supposedly, and didn't see the problem. So, hey, great. Let's build the game. Let's run the game. Hey, let's build the tests. All right, so we can take this out. All right, so this is good. Now we have good semantics everywhere for these things. In theory. I now owe $1,500. Is that the going price for telling me I put A instead of B? All right, well, GG's. Whoops, that's the wrong thing. We're looking for no check-in. Commits. Okay. Now I still don't know if so now that this is there, I don't know if I should be setting those like signed wrap flags or whatever. We're currently not. Well, I think it's break time. Shift wrapping is referring to the wrapping of the LHS. Right, I see, yes. And we want to allow you to shift into the sign bit and that sort of thing and shift bits off. All that is fine. We do not care, so we should not set those things. Are there any on-topic questions about what we did before we temporarily have a gaming stream? And then after the gaming stream, I think we'll go implement the modifiers that I parsed earlier today. How is it 7 p.m. already? How is it 7 p.m. already? Time flies when you're having fun. Well, it's so funny because like yesterday I was like, hey, we did all this in one day. But then of course we had to spend the majority of today doing this on backends. Although it's only been this stream, right? What did we do? Oh, right. So this morning stream, we did a constant expression version of this, didn't we? I don't even remember. And then this stream, we did x64 and then LLVM, which was pretty good. And then yeah, we're mostly done. I'm a little bit tired of thinking about bit shifts right now, but the next step is going to be working on those modifiers. If you want to be productive, don't look at time. That's true. Sometimes looking at time helps though, because if you're kind of dithering and you're like, oh my God, it's 4 p.m. already or whatever, that's helpful because then you're like, I better get my butt in gear. Yeah, we've been working on, I already explained it for like several minutes, but operator shift implementation in various ways. And because compilers are hard, we had to implement it 4 times, right? 2 backends, third backend for the bytecode execution, and then constant expression evaluation. Oh, that's the other thing we did today, right? I always feel better when I just remember back over everything, right? We actually, in the morning, didn't have good behavior for the runtime execution for shift, right? Yesterday, what we did was we implemented rotates. I got totally confused, right? So yesterday was rotates. Today, we started by fixing the semantics of shift operators. That's great. No, we did all this in 2 streams today. If anybody uses this language, we've saved people a great deal of pain of having undefined behavior in one of their basic operators. Assuming that everything is done correctly, which it's not. There's probably bugs somewhere, but we'll find it later. If anybody uses it. Well, we already have 20 people using it. Do I have a big apartment? I don't right now, and I'm wishing that I got my act together and moved to a bigger place. I'm pretty happy. Like this, yesterday and today have been really productive. And again, part of it was getting this off the list. Like for a long time, I was like, we're just inheriting the crappy C semantics for the bit operators right now. Blah, blah, blah. But that's a sign of good progress is when you finally just really start eliminating these things. Yeah. Because it was always, it was always part of the story, like, well, at some point we're going to fix the bit operators by doing, etc. But when you start building up too many stories like that, you start thinking, are we really going to ever do those things? And like, yes, we are. It just takes time. It's just like video games. You spend the time and you get it done. Let's go to gaming stream for a while. Thanks everybody who was here for programming stream. We're going to do brain break. And then we'll do some more streaming. After gaming, we'll see how I feel. We might do we might do a total stream break, or we might go straight back into programming. It depends. It depends. We might be running out of will to play Dungeon Warfare 2 also, because at this point I'm just doing the same thing all the time. Let's turn this down. It's going to be too loud. All right, we're gaming. Keep. Tier 9 castle map. Destroy the vault in 5 minutes. Like at some point, these maps aren't adding anything. It's like, okay, so we're just going to put a thing there. Why wouldn't we put a thing there? And then we're gonna destroy the vault in 5 minutes. And then we're gonna do these thingaboppers. And then we're gonna I mean, let's see how long this lasts, but I'm gonna force people down. And then we're gonna put a thinger here. And then we're gonna, oh, we can't put a dude. Okay. We're gonna put regen on this, even though it's expensive. Trap foundation, and we're gonna want to put a demon dude on there, but we can't do it yet. Start game. I think we'll get that in 5 minutes. Would I ever consider teaching in some form? Yes, I would. All right, we're starting to get money. I need to swap out this dumb nail gun thing. All right, this dude's gonna be there. Rearm, minion damage. Uh-oh, dwarf bombers, they're gonna screw my stuff up. Oh my God, look at all the dwarf bombers. This is really not that good. I feel, I have a bad feel. Oh, I can't. Did the dwarf bombers just not make it over those? Wow, okay. Stupid dwarf bombers. So if I break this, is that just for experience? Like, I don't even know why I care about those. Uh-oh, the wizards are gonna summon. Oh, man. Okay. We need to start culling the wizards. Oh, except my added force got the guy. All right. All right, only one golem made it. I unlocked a new consumable trap.
Juicy.
Wizard's gonna get toasty. Bye, Wizard. Like, this guy's just hanging out. He's like, I don't even need to do anything. Okay, so now we're starting to get bigger dudes here. Okay, this guy is gonna jack my thing up here. Oh, you got both of them. Okay, we're gonna need to do some stuff here. Oh no, my Demon Lord wasn't powered up because he fucking hadn't fought anybody yet, or fracking hadn't fought anybody yet. So now I'm in trouble. Okay. So my problem is they're gonna keep busting. Oh, they busted my, oh, they destroyed the spawner. I didn't think they would do that. Okay. So that's the we're gonna need a new strat here, because we could try to save this, but okay. We're gonna rip this and restart. We might be able to live, but so this part is working. This part is not really good. What we want to do is put like a last stand here. Or something like right here. Or honestly, I mean, we can fight guys up here, maybe? I don't know. Okay, let's just try to save it for a bit. See, I don't have harpoons, which is the problem. Like, harpoons, I could do this. Let's just start laying these down and see if they help. Wait, how did that guy get thrown off? I don't understand that. Oh, look at all the golems! I don't have a Demon Lord anymore, man. If someone gets up there, I'm hosed. And it took so much money when that got destroyed. I should have, because I had to build the trap foundation and all that. I should have put him back here, maybe? Or maybe this just isn't a level where you do that. See, these guys are going to own me. That other one got really damaged down here, but this guy, I don't really see what I do to him. Like, does this damage this guy? I don't think so. Now we're in deep trouble. I think it's GG's. Maybe not. Maybe I can just tank the freezes, which is the other cheesy thing about this game. I just want him to get on the springs, freeze him. Nope. Freeze. Freeze tag. Oh, there's 3 guys. Okay, this is RIP. RIP and GG's, guys. All right. Let's get better. Let's get rid of this stupid thing. We'll get harpoons. Oh, harpoons are not leveled up. Teleporter we didn't use. Teleporter would be good. All right. Here's our plan is no Demon Lord this time. Rocket Trap. I mean, I thought Rocket Trap sucked the one time I tried it, but it's been so long. Let's try it. Just, you know, we're going to try some different things. So Rocket Trap and then harpoons, because we have like super harpoon mastery anyway. I don't know where the harpoons are going to live, but whatever. What are we going to trade out for harpoons? I need to get rid of some of these items. Okay, let's get rid of these. Greater puzzle. Bolt trap. That's actually pretty good. That's a good blue item. Okay. Look at all these items I have. I mean, some of these are probably good, but I don't remember. Yeah, I don't care about that. All right. Okay. We could get crazy and double harpoon boost. This one's actually better. This one's tier 2. This one's tier 9. Actually, let me check these. That's tier 7. That's tier 6. Dude, I'm using the not good one. 45, 54. Oh my god. Oh my god. Let's check this one. I assume these were all duplicates. Tier 9, 171. Tier 6. What am I doing? Except we're not going to use minions in this level. This is not that good of a minion level. All right. Let's try Rocket Trap. Wait. Where are Rocket Trap? Harpoon. Yeah. Okay, let's just, again, set up a bolt for this guy. Whatever. That's going to get destroyed. Going to put a block down. Okay. Rocket Trap, do I just want to put it here, like in the open? Do I just want to, like, put it here and dust guys as they come out? I don't know what rockets are like. Put them where you can't use other stuff. Okay. But like out here, I'm not going to use it. The question is, do I want it early or do I want it late? Like, what's the range? Does it tell? Oh, okay. That's pretty good, right? Okay, here's what we're going to do. We don't want this to waste time shooting at little guys. So we're going to put all these like dumpers that we had, we're going to put them down here to get rid of the little guys. All right. Also, this has the benefit of getting wizards before they frickin' spawn. Golems, right? Okay. So like, that's going to get rid of the little guys. This is going to shoot at dudes. Rearm speed, knockback. Damn it. I think damage, right? And then we'll have like some freezes up here. I bet we can increase the range on the rocket trap as well, right? But we're gonna put a freeze. Maybe that corner spot is too valuable, but whatever. Okay. Starting. Wow, it feels so weird to not have a Demon Lord posted guarding the castle. Okay. Then we'll put a second freeze to do the freeze already chilled. Freeze already chilled guys. It is Doom-like music. That is true. All right. And then we'll do Frostbite when we can afford it. All right. Now we're going to save up to buff this rocket trap for damage. That didn't take long. Double damage. And then what? Units on fire increases activation range or increases explosion radius. I kind of don't need activation range in this position. So I think explosion radius is the call. Oh, explosion radius and damage, yeah. All right. And then 8 small rockets. %50 radius is kind of ass, but if they seek different things, then it's good, right? Let's try it. I mean, we already got our radius boost, so a bit of a radius decrease is maybe fine. Swarm rockets. And then we'll just save up for another rocket trap, which we've almost got the money for. So we'll do physical force on those two. I said I was going to save up for a rocket trap, but then a bunch of guys showed up. Among them, a wizard. That's fine, though. We'll have the money so fast. Uh-oh. A dude got through. Rocket him. Oh, yeah. Oh, yeah. Okay. That's working. We don't want to waste that on this guy. Soul Harvester. Soul Harvester doesn't... I don't know. Maybe I haven't tried the level 15 upgrade. It sucked. Maybe if I had one here, I would actually be getting gold for all these guys. But at lower level Soul Harvester, you don't actually. Okay. Let's start doing some poonage here. Does that reach? No. Nope. I just want to slow these guys down a bit. So now my worry is that we are not really ready. Oh, Jesus. Okay, well, I mean, all right. So we actually want some dumpers over here for little guys, like, because if we blow up a vehicle like that, you just use 3 traps: Liches, Lightning, and Soul Harvester. I could imagine that. Maybe I should try that sometime. I mean, on this map, you don't really have a place to put the liches at the end, so maybe you'd put them like here, and then lightning here, and then you'd soul harvest like there. Yeah, that's the thing about this game is it does seem a little bit exploitable. Bolt is really good for me because I have lots of items that like magnify bolt. In fact, let's put one right there. In fact, if our theory is that nobody's going to get by, then we could put like Snowpiercer bolt back here, and it'll help with these situations. As soon as I can afford that. Let's not. We don't need that. We don't need Snowpiercer bolt. Well, rocket traps were bad when I tried them, but it might just be that level 1 rocket traps are bad. Because that's like back when I had it. Let's see how rocket trap does against these guys. Okay, so we want a dumper for guys who get this far. All right, let's see what happens with these truck wagons. Curse totem. Cream those guys. I think we get another rocket trap up. You just have to do damage. You know what? Why not? I may regret doing this, depending on how bad. Okay. Oh, that's not bad. Do I have to wait till these guys have their back to the rocket? Like, are they just heavily shielded in front? Is that the deal? Maybe. Do I have Singularity skill leveled up? I've got a few levels into it, but not a ton. Trap booster. I must have a ton of runes at this point. Let's see what my Singularity's at. Which one is Singularity? Is that, yeah, level 5. I mean, that's pretty good though, right? That's actually good. So I gave up 50% rearm speed by adding that second rocket. So instead, if I do rocket and axe, I get 50% on each. That's pretty good. What was I doing here? 1% more gold from all sources. Okay. We're probably not really going to use Harpoon. We'd probably rather have minions. I mean, that's... If I was using Harpoon, usually this would be really good. Even though it's just blue. Should I cash in some of my browns and see what happens? the same at tier 2 and tier 5. Be careful. I mean, this, let's try this. Or actually, no, because this is a worse version of something I already have. Although I could stack these. I'm more likely to want to stack these than want this. So let's see. 9 browns, what happens? We just got a brown. We got a mediocre brown. Yeah, but it's not something good. I was expecting super brown or white. However, this is starting life doubled and plus 8 XP, which honestly isn't that much. This is starting life is doubled, plus 5, plus 19 per kill. Okay. This is way better. I might have had the wrong Hematopus. This one's tier 4. I got an achievement. All right. I mean, at this point, what do I do but just keep leveling up the items that I use all the time? It's not going to matter that much. Pro tips. Let's go here. Let's look at our runes. Look at all this. Nope. I think if you mix colors, it's probably bad, right? I got a brown rune. 5 horsemen spawn every wave. That's entertaining. That's entertaining. That's a better rune than a lot of runes. %, increased enemy 206 XP bonus. That's pretty good. Enemies have phasing. That sounds scary. Start with 11 life penalty. 2 totems. What are totems? Whatever. Let's move all our stuff onto page 1. All right. Not like I ever use runes, but we've got some runes. I feel like a lot of common runes are easier challenges with higher XP. I don't know, my common runes were like, I guess 31's pretty high. But like 200... This one's not that good. 100, 200... All right. What are we looking at here? We have a vault, which I guess we want to bust open. If we do, that kind of ruins our enemy pathway. How much money is in vaults? I wish you could tell. Maybe you can. I mean, really, if we're being honest, this is how we start this. Oops. And then maybe we just rocket trap some dudes out here. Enemy damage doesn't matter when you're not using minion traps. Well, it also matters against barricades. Okay, I could put a rocket trap here. And it'll start by destroying this. And then, okay, I want to put it one north, I guess. I want to put it like here. Here? Yeah. So I want to put it here. Because then it'll just own dudes all over the place once this is open. See, usually my strategy is to pin people into a very narrow thing, but like today that's not going to be the strat. Let's just start. I guess Rocket Trap without Singularity probably doesn't shoot that often. Okay, now we're in trouble. We didn't make enough things. We could Demon Lord it up right here, by the way. Oh, we didn't bring them. Didn't bring Demon Lords. This thing, okay, this Rocket Trap plan was not the play. It is very slowly. It's not spending that. We're going to need to help out this Rocket Trap here. Won't that fling people over the lava? No, because they're like artificially heavier a lot of the time.
Bloody.
know what we really should do is sell this. Shouldn't have sold it yet. This guy not taking damage from lightning? Like, what's his deal? Dudes are coming out the other side now. There we go. We broke our thing. Which maybe this is stupid now that we broke our thing, but whatever. Oops. Okay, so now we kind of have a problem with all these big dudes. We're gonna harpy these guys. Freeze! Damn it, bro. I just didn't... Oh, these don't teleport. Bro, they don't teleport. I'm so dead. Except I have so much life that I'm not so dead. Ugh. Dude, see, if I had my Demon Lord there, I would have been fine. Alright. Spin blades? Who would use a spin blade? Dude, there's so many of these battering rams. They're just everywhere. See, the teleporter fires and the battering ram doesn't teleport. That's the flaw. I thought it would teleport battering rams when I set that up. All right. Swarm rockets. Oh, I forgot to bring axe too. All right, now that we have swarm rockets, we're kind of unstoppable. Spin blades tend to have more damage than spikes. What's my meta level strategy I'm going for with trap synergy? I don't know, man. I'm just playing the game. Like, what I find is when I make a really good bolt thrower, that's just my best thing, and then I funnel guys into that. And then I have things to clean up after that, like a demon lord and a teleporter. Now the thing is, I haven't really been doing that here because the map's sort of not conducive to it, except it is. Like this one would be a fine Snowpiercer, and I just didn't set it up. So that's good. This is like my master unit usually. This rocket trap is a new thing we're playing with, but it's also really good, so. Like, this thing just owns guys, though. Like, especially you freeze them on top of these things, and, you know, if they're not super heavy, they all get thrown up. But this whole level is a wacky experiment that's unlike what I usually do, because like I was like, hey, let's just put a rocket trap here. This is probably not how I'd usually play it. Knockback Golden Piercer. That's interesting. I usually pierce from behind because then it'll shoot more often. Because if you pierce oncoming, you kill the guys and then you have to wait for more guys to show up, right? But if there was a constant onslaught of guys so that that wasn't a factor, then it's good, right? So I don't know. I don't know, man. This is a pretty weird and honestly kind of weak sauce setup that I have going on here. Well, I didn't bring my thumper thing for these guys, so rip that. Some freezing by the big damage hallway. Yeah. You mean here? Yeah. I agree with that. The problem... Oh, I can't put it there. Ooh, I took a damage. The problem is I can't... Because I don't have the thumper thing, I can't force guys to come that way. Now. From over here at least. But they still come that way from there, so I guess it's worth it. Like, I just scrolled instead of clicked on those guys, so I missed them. But this is bad. Like, once you get to this point, this is just more of a mess than there should be. I'm just not dealing enough damage. I'm kind of just tempted to throw this and start over. Like, okay, so the flaw in this plan is the rocket trap rotating takes time. I don't know. It would be better like down here. This is going to be bad when this one pops. See, this is bad placement. Like, I should have another smiley face here. My lightning should be down one because there's no reason for it to be there. You know, all this could just be better. Oh, and now they covered that. Okay. Well, never mind. Let's just redo this. And I want to get it set up so we can crank through it faster. So rocket trap is fine. This is fine. This is fine. This is fine. What do I not really need? Barricade, not really. And spikes, not really. And I can replace that with some Demon Lord action and some what was I thinking? Oh, this thing. Whoops. Right, so we get this thing to blow up the lava coverings. We could preemptively place that, and then we get this guy to guard our base. Springtrap becomes a liability. Yeah, it's true. It's good on this level in the beginning, but it'll stay good. The problem with the Springtrap is it got neutralized, but we can unneutralize it with this, so it's actually fine. We're bringing items that make it better. So we're going to reset this up because this was very successful in the beginning. I'm maybe just going to start setting up my defense here instead of up there. I don't know, we could do one just to do it. Okay, but then we're going to preemptively do this. And that'll maybe slow down guys coming from this side a little bit too, but really we're just keeping this alive. Actually, screw it. I mean, we don't need to build these for a while, but yeah. All right, I don't remember how much gold was in this, but we'll get it eventually. Actually, that's stupid. Because, assuming this stays up, we really want to be... And then we'll get this guy here. Let's just start that. Demon Lord. So we kind of have to protect this guy for a little bit. And then he's good. It's just he's a little squishy in the beginning. Except the base is getting dudes before he does, so it's fine. Alright. Let's Snowpiercer this up already. It's not going to matter that much in the very beginning, but... So we're just going to cover this guy for a little bit while he beats up some golems. No, don't die, Demon Lord. There, thank you. Okay. Because I think his HP resets if he dies. Alright. Let's put another one of these here. Alright. So now our problem is we're going to have these big beefy dudes coming down. And it is a true observation that we could really use some freeze here. I don't know. Move Demon Lord, deploy up 1 square. What? That's the wall. Oh, you mean forward 1 square? We could do that. Let's let him fight this guy off. Because it's true that anytime this is powered up, we don't want to waste these on dudes. So we're going to go there. So yeah, I think his HP are reset, but he didn't have that many kills yet. Alright. Let's actually start plinking away at this. Oh my god, I have so much money. What am I even doing? People, what am I doing? Uh-oh, they're going the other way for some reason. Don't go the other way. Look at all these dudes. is going to be bad. Wait, what happened to my Demon Lord? I haven't been watching. He's gone. Why is he gone? What happened? This was supposed to be the good playthrough. Now he's back. He must have died when I wasn't looking. I thought he was fine with all the lightning and stuff. Forgot rockets, that's true. The problem is, while these walls are up, maybe I'll put the rockets out here. Oh, I'll put them down here. Okay, we almost can afford rockets. Problem is, because my Demon Lord died, he might get owned right here. I think I just ran him over. No, he's still up. Still up. Come on, buddy. Oh, I think he just went down. No? Yeah. He just went down and got resummoned, I think. Damn it. Damn it, bro. That'll teach us not to have our rockets up. Yeah, he does need rocket protection. You are correct. Instead of building this freeze, I should have done the rocket first instead of this. Like, look at that! Look how much better that was. It's like not even in dispute how much better that was. Just wait till we actually do this. Yeah, like why did I build all this stuff? It was the wrong order. How's this guy doing? 248. Not good. There we go. Now we actually are doing the plan. Like, why did I put this harpoon here and this, and it doesn't rocket scales with gems really well? I mean, it's level 15, but I guess I can keep dumping gems in. Why are these guys just running past my Demon Lord? All right, I guess I make more lightning now. I don't know. I feel like shooting at the choke would deal massive damage. Like if it was over here, maybe. Or do you mean this? Or do you mean this? Yeah, the problem is there's guys over here too, and I want to have only one rocket because of the reload speed bonus from Singularity. So, alright, how's this guy doing? 253. A little bit better. Getting creamed. I'm going to try this amplifier thing. I don't usually do this, but wait, did I miss amplifier? What? There we go. Come on, Demon Lord. You can do it. You can do it. I mean, one thing I could, if I brought Barricade, I could barricade these two and have just everybody come down through here. I don't know. It's just a waste when the rockets fire at single guys back here, you know. 267. Well, we're doing way better than last time. Oh my god. I didn't... Oh no, never mind. I thought that was the gold option. I was like, I didn't do the gold option, but I did. Oh hey, somebody blew this up. So now we can do this. Now we can zap across the wall. Oh no. Oh, it does. It goes slightly... So really, see, this is my super lightning trap. I should actually sell that. Upgrade this to super lightning trap. And then make this a regular lightning trap. That way, this one is speed boosted. Although I don't feel like the top level boost, the 3 additional units thing, I mean, it's okay. It doesn't seem that great, but it's better to have it on the speed boosted guy, is my theory. Two, 7, 5. Actually, I should have put this... No, because that's under the demon mode. You guys are getting creamed. Alright, we took a little bit of damage, but it wasn't bad. Three by 3 lightning upgrade stun locks people. Yeah, it's quite possible that that's what would happen. I don't know. Base XP 1.5 mil. All right. Is it in greed that lightning damage stuns? I mean, if I'm going to be using lightning a lot more, I might as well crank it. I don't know why that's under greed, but okay. I mean, that's not bad for a blue. I'm getting hungry, everybody. I mean, what am I going to do with all these gems? Pour them into Rocket Trap? So we went from 350% to 5... What? All right. Now, because we were saying this is good, I guess, I'm going to try it some more. So we're going to try to swap that in for something else. Okay, so bad guys can bust all this open at some point. Are there other... No, no other entrances. So really, I think this is... I mean, it's kind of a barricade occasion, right? Like, you want to barricade this and have guys at least to come from here and have some axe action, right? So, okay, I want barricade. I want... We're not really using teleport. Harpoon, not really good. Barricade, axe. So we're gonna go like high money build this time. All right, we're gonna barricade there. We're gonna axe them a question here. And then we're gonna rocket trap them at the end. Or we could rocket trap out here. I mean, honestly, if there's only one entrance, why don't we just nail him here, right? If I put it back... See, I want to actually keep him from shooting at guys to the right. The question is, do I want to shoot at, like, everybody, or do I want to wait? If I wait, then I only get the big guys at the end, which is good. Oh, I'm not going Harvester with high... Oh, yeah, let's try that. So what do we swap out for Harvester? Maybe this thing, because we don't know if we need it. Maybe freeze, honestly, because there's not a lot of places to put a freeze on this level. All right. So what if I put a rocket right here, shooting into here? I mean, what if we're just ridiculous and just do everything in this box? And then maybe Demon Lord picks up the change at the end, right? So like, freeze him at the gate? Yeah, maybe. I think lightning here. I think we fill this with lightning. We do. I don't know where to put this. I mean, that's like a valuable spot. Increases area. I mean, we could do this. See this? You have to get 200 guys for this to even pay off. If it's buy, I don't know if it's 2 or buy, but if it's buy, we need 200 guys for this to even break even. It doesn't feel good. One more barricade and they're forced to go left. But I don't want them to go left. Perfect hallway for bolt trap. You mean this? I mean... Okay, here's what I think. Okay. Yes, but we do it like this. Oh, but then, screw it, we're gonna spend an extra one. Because, wait. No, it's not one more barricade. Hold on. So we had one here. It's 2 more. Right? problem is now it's 3 more. This becomes very expensive to set this up. But we're going to do it anyway. That's like all our money. And we don't have any frickin' passive income here, which is ass. Oh my god, there's dwarf bombers, dude. Okay. That may negate this whole plan. Yeah, okay, rip. So I don't know if they will go for, let me see if they go for that. No. So they have to be kind of close to a thing. He just fell for no reason. Okay, they'll go for it here. Oh, dude. That's lava. Oh, that's great. That's a good, that's good. Because then this becomes a 1 square bottleneck. I mean, it already kind of is, but it becomes a straight out. But then I can shoot, yeah. So we're going to go back to this plan. We're just doing this. Okay, the Soul Harvester is kind of working out so far. So then we're going to get our adjacent trap boost from that. We're going to need to put something here to block these guys, but we're too busy raking in the money right now. Gold 145. See, it's not even that high yet, but we'll see. I guess I'm going to do this. All right. So we're going to have multiple adjacent units. So if I put these adjacent, they get the power up from this, and then I can also put an amplifier here, and it'll just be stupid. Although I could just put a dumper here. The thing is, if I throw guys into the lava, I don't really... I think guys who die in lava don't give me money. Like, that was my big beef about this thing before. Alright, this is not going to be good. Alright, I don't like these bomber dudes damaging this thing, so... Well, we're just going to have to do more damage up here. Do I want stun duration just to keep guys in? without numbers, I don't have any way to make the call. Earn gold 568. Like, we still haven't broken even on that thing. Okay, and then here. Oh man, don't even. Ugh. These guys are jerks. That was a waste of 500 gold. I should have sold it real fast. Okay. Oh man, there's little diggers. Alright. Spin blade would be good. I've never gotten spin blades, honestly. Never felt that I understood I'd never studied the spin blade, as it were. When they spin, they block the square. I guess that would be worth it. But the problem is, then won't guys temporarily path around it? That could lead to problems. I guess it doesn't spin that long, but... What was that? Bro. Should I actually move this guy up? What was that? My own rockets shot my thing. That's lame. Earn gold 1,000. All right, now this is starting to sound good to me. I mean, it probably costs fair bit. Well, I spent, if I sell for 1462, I probably spent like 2,000 on it. So like it still hasn't broken even. It doesn't affect pathing, they just get stuck on it. All right. Ugh, those guys are too fast. Why is my Demon Lord looking the wrong way? Just like guard the area, dude. Alright, what else do we do here besides build more lightnings? Oh, we never used our axe. There's not really a good place. I mean, I could put it here. I could be a dick and just put it here. What's the radius of it? It's not that big, so... Like, ideally I would want the axe and this in the same place, but there's not a place for it. Soul Harvester right at gate. I mean, dude, this one hasn't even broken even yet. Or maybe... I don't know. Right around now, it's probably broken even. I didn't get freeze. I could almost just like freeze him right here. Like these bolt shooters, they shoot too soon. They like miss the first guy. It's really annoying. Alright, you know what? Screw you guys. Too many guys are getting out of my zone. If all else fails, you point blank bolt everybody. Point blank bolt. Because we have a bonus for that. Those wizards sure like summoning golems. Alright, now we're starting to get some earned gold here. This rocket, when there's people who got past it, it gets so confused. Alright, maybe I shouldn't have rushed these waves. Because maybe a little bit overconfident. That axe didn't do any damage to these guys. What's going on? Oh, there we go. It's still not doing that much. 3 times per activation. Let's do it. It's only 3K gold. Why only 1 rocket? Well, we get like a 50% rearm speed if there's only 1, you know? And so like, and a second rocket can't be like a super rocket anyway, so it's questionable whether 2 rockets is any good. So you'd have to go to like at least 3. Although at this point we could do that, right? We can just rocket. Let's try this and see how it feels. Oh dude, our barricade went down. Maybe that's fine. Maybe we don't care about that barricade anymore. Yeah, like I'm not sure this is doing better than the 1 rocket was. All right, well. I think that's going to be it for now. I think we're going to take a break and then we're going to do another programming stream at night. I kind of would like more gold from all sources. Tier 12 ethereal map. I've been programming all day. I mean, it feels that way, but like also I could do more. All right, thanks everybody. I'm gonna take at least 30 minutes off, 45, something like that, and then we'll come back and we'll do some programming. Enjoy playing your own Dungeon Warfare 2.